Good evening. Is voice clear? If voice clear, I will start. No, voice clear. Some comment came but vanished. Voice fully clear means you are not commenting. Good evening. Voice clear? Clear. Okay. I'll start now. See. Don't see this side. See. This is a result I wrote, prepared earlier to save the time. You never bother this side now. We are actually here. See. We are here. That is, after analyzing the frame by SD method, MD method and Kani's method, everywhere finally we got member end moments. Member end moments. Then I wrote what? Then I wrote go to where? If you remember, after getting the end moments, then I wrote what? Go to. What is the usual statement? After getting the member end moment, SD method over, MD method over, Khan is over. Methods are over. Then I write what? Go to. If you remember, after completing every method, what I will write? Moments are over. Go to where? You are not responding. Every time I used to write, different methods are used. Method will give only member end moments. That's all. Then I told what? Go to. Nodi, you are not answering. You are writing message and deleting. Same time you can use for writing message. Go to where? After getting the member and moments. No, I never write. I give a simple language. SFD BMD letter. What a name I used to give? No, I used to give a name for you. SFD BMD comes there. Okay, you are telling SFD BMD. I used to give a name. See, just to understand, common part. You are not following. I used to write always go to star. Go to star. So, our star. Our star starts from here. Here. This is not required because already over. This is already over. This is also already over. Okay, start. Now, just to understand. This is the frame we that C is missing there. Okay, I don't know why. C. Okay. This is the frame we analyzed by slope deflection method, moment distribution method, and Kani's method. Each and every method will give you final member end moments. MAB, MBA, MBC, MCB, MCD, and MDC. Yes, this is the result. Tell me, this is the result by which method? Result by slope deflection method or moment distribution method or Kani's method. All the three methods we got same answer. Okay, now up to here, see, this is already over. Now to draw axial force diagram, actually SFD BMD, we will also draw axial force diagram for this frame. That is, today's class starts from here. Now, why I wrote the question once again? Because when I want to find reaction, I should see the frame. If I write a free body, then I would keep on asking you, what is the length, what is the load, etc. Okay, then, why I wrote EI value? EI value is not required. I wrote because, suppose somebody is new. He came today's class and he thinks, I know how to solve by SD method, MD method and Kani's method or any method or so many methods. Yes, you start, you analyze and remember, get the same answer. If you don't get the same answer, you are wrong. Correct? If somebody solves independently, he may tell, I do not want your class for SFDB, MD, for what SDM, MDM, Kani. I got enough knowledge. I am expert. Okay, you are expert, solve. Then why you came to my class? I want to understand, I got a confusion for axial force diagram, shear force diagram, bending moment diagram. Those methods are, he may tell, I am expert. Okay, if you are expert, you use your expertness and analyze and get the moments. Okay, now clear? Use your expert knowledge and get the moments. Okay, start. Now, nobody can tell, I am not getting the answer. If you are not getting the answer, you have done some mistake. Okay, now, to draw axial force diagram, shear force diagram and BMD. What we will do is, to correct, see, what all I tell you write here. See, class, what all I tell you should write, if you want to understand. What we will do is, when you go to star part, see, our star starts from here. Here. To understand correctly, you draw a line diagram. One member here, small gap, member here and member here. And enter whatever moments you got. Remember, all these moments are based on sign convention, clock. I told you, whatever I tell you should write. Tomorrow you tell, sir, you wrote anti-clockwise. Earlier class you told unknown should be taken clockwise, but you wrote anti-clockwise. Now it is not unknown. That's why I told. These moments we got by SD, MD and Kani. Now one more thing. Completely forget. Now I do not know what is SD method. I do not know what is MD method. I do not know what is Kani's method. I know only one thing. Each and every member, there will be member end moments. Because support here, fixed support here. Rigid joint has got moment, there will be moment. So those moments, somebody gave me. Someone told, these are the moments, end moments for each and every member. Okay, he will tell me, now come on. You start and draw axial force diagram, shear force diagram and bending moment diagram. Okay, done. Now, these moments we got, all these moments we got based on sign convention, clockwise positive. Therefore, if you write the value as it is with sign, if see, I told what all I tell in the class you have to write. If confusion comes, you are responsible. Every sentence required. If you are going to enter the moment with this sign convention, suppose when you enter moment here, you want to write plus 0.12, plus 91.27, minus 91.27, plus 18.4, minus 18.4, plus 57.29, then those moments should be entered in what direction? Tell me. If you are going to enter the moments with sign, those moments should be entered in what direction? I will not tell again and again. Those moments should be entered in what direction? This I told you earlier. If you are going to enter the moments with sign convention, then compulsorily you have to enter those moments in clockwise direction. Why? Because as per sign convention, clockwise. Suppose you want to write 91.27 clockwise positive, negative came. Suppose I want to enter only 91.27 without sign. Tell me, only 90, I want to write 91.27 kilonewton meter. No sign. But I want actual direction. Then 91.27, this moment and this moment should be entered in what direction? No. If I am writing only 91.27, no minus sign, then I have to enter 91.27 in what direction? I will not repeat. Then I have to enter 91.27, this one, this minus 91.27, I want to write only 91.27. I should enter in anti-clockwise, no plus minus. Tell me, fully clear? Full clear first. Full clear or not? This is a major mathematical problem for more than 95% people. I will tell once again. If you are using a sign convention and got the values, then if you are going to enter the values result with sign, you should enter it in the direction as per sign convention. Or if you do not want to enter the value with sign, if you want to only enter numerical value in the actual direction, then anything you got positive there, you should write the moment without sign in the same as sign convention. Anywhere you got negative, you should enter numerical value in a direction opposite to sign convention without sign. Clear? Last statement. In future I will not tell. Clear? This I cannot tell in future. This you go through 100 times. You are not telling. Clear means okay. Second time I told. Later you should not tell. Sir, last time talk wise like that. People who understand go through my class fully, only for my class is useful. Okay, start. Now enter the moment. I entered here. See. Plus 0.12. Clockwise 0.12. Plus 91.27. Clockwise 91.27. Minus 91.27. Anti-clockwise 91.27. Plus 18.4. Clockwise 18.4. Minus 18.4. Anti-clockwise 18.4. Plus 57.29. Clockwise 57.29. These are the what? The member end moments. Write a note here. All are in actual directions. No sign, nothing. Okay, start. Now, to draw axial force diagram, you require the force along the member. To draw shear force diagram, you require the forces perpendicular to the member. To draw bending moment diagram, you want moments and also forces perpendicular to member. Clear? See correctly. I am telling only one example. If you do by suppose software, you get the result. If you want to draw axial force diagram, you require the forces along the member. If it is a vertical member, I want along the member, vertical forces. It will create compression or tension. If I want beam BC, I want along the member. This way is tension, this way is compression. Same way for CD. If you want shearing force diagram for the beam, you require forces perpendicular to member. If you want column, for shear force diagram, you require this way, horizontal forces. Same here. And to draw bending moment diagram, you require same as shear force diagram plus extra moments are required. Clear? Fast. Clear? Fast. Make this note 10 times. You are not telling clear. Old clear. See? Not answering. I will tell systematically now. Don't worry. Okay, now. See. If you know the member end moments, remember, when you consider free body of a member, you can only find what? Tell me. If I write free body of a member using member end moment, using sigma m0 or sigma v0 or sometimes sigma h0, you from equilibrium condition using member end moments, you can find only what? Tell me. Using equilibrium condition, If you write free body diagram for a member, you can find only which one? Tell me. You can find only what? Only horizontal force or horizontal reaction or vertical reaction. Tell fast. If you write free body of a member, apply equilibrium condition, you can find only horizontal forces or vertical forces. Fast. Reactions, okay. Horizontal reactions or vertical reactions. Fast answer. You should answer fast. Don't delay unnecessary hours together. See, usual problem. No reply, nothing. Then why I am asking question? When there is no answer, I have to keep on waiting for the answer. Then it will become E-TAP class last time. I may close the class and go. I will record. See, I asked you 2 times. Third time I cannot ask. Sorry. I asked 2 times. Third times I can't ask. Sorry, not asking. No, not asking. Asked 2 times. Okay, I will tell the answer. If you sketch the free body diagram of any member and you enter the member at moment and reactions for the member, then using equilibrium condition, you can find only reactions normal to member. That is, those reactions which has shearing effect and bending effect. No axial forces. Because if I take a member here, for example, if axial force is here, one reaction here, 2 unknowns are there. You can't solve it. So, if you consider free body diagram for a member, you can get the result or reaction which are used for which one? Tell me. Axial force diagram or SFD BMD. By considering free body diagram of each member, what reactions you are getting? You will get those reactions which are used for what? Either axial force diagram or second is SFD BMD together. Which one? Tell me. 2 groups. One is axial force. SFD BMD together. Which one? SFD BMD. So, if you want axial force, you require some extra concept, I will tell. So, therefore, right here, first what you do is, first consider free body of all 3 members. Separately and find what? Reactions normal to those members. That is, if I take the AB member, find this reaction. If I take BC member, find this reactions. If I take CD member, find this reactions. Direction I will tell later. Clear? For AB, this reaction, not axial. Axial will not come. For reaction, I told normal to member. For AB, get this reactions. For BC, get this reaction. CD, get this reaction. Clear? Past. Okay, start. First you do it. But remember, direction of reaction, if clear for you, 100% guaranteed, assume in the correct direction. If you are 100% sure, assume correct direction. In case doubt comes, what to do? Direction of reaction. In case doubt comes, what to do? Suppose doubt comes, horizontal reaction, right side or left side. Doubt, don't see SDMD Kani now. You do not know SDMD Kani. We are in actually engineering mechanics. Remember, we are in engineering mechanics. Tell me, if direction is confusion, what you do? Tell me what to do. If directions are confusing, Suppose you are not able to decide direction. For example, horizontal reaction here. Doubt comes. Right side or left side. Doubt comes. What to do? Assume some direction. When you solve, use any sign. If it comes positive, assume direction is correct. If it comes negative, assume direction is wrong. So, if you get positive, next time when you go to free body, enter the value in the same direction as assumed. If you get negative, later enter the value without sign but in a direction opposite to assumed direction. Clear? See, structural engineering has got lot of mathematical concept. Lot of concept. So much of mathematical concept. So many people, I will tell you, it is not 95%. I am guaranteed. If I have to trap someone, I have got confidence. I can trap 99.99999% people. I am sure. Maybe, sorry for having so much confidence. My confidence. If you bring 1,000 people, I am sure 999 people I can trap. Maybe one. Okay, he may be equally competent. With him I will tell, oh, you got beautiful concept. Sorry, we are friends. I will tell him that way. Sometime I will tell, no more testing you. You got perfect knowledge. Therefore, we are friends. Leave it. You are not in the group. Others all, I can easily trap. Ask some questions seriously. One after another one. See how they will fall to the trap. Okay, start. Not for boosting myself, I told, because it is a reality. It is a reality. Do you agree? It is a reality that majority, more than 99.99% got confusion. They are open for trapping. Whether you agree or not, it is a reality. Okay, start. Now, first step. Calculation of reactions normal to member. Normal to members. Very, very important. Members for AB, BC and CD. Remember, here AB is supported by BC and BC, actually BC is supported by AB and BC is also supported by CD. Do you agree? This beam BC is supported by AB and BC other side supported by CD. Do you agree or not? Do you agree? Beam BC is supported left side by column BA, right side by column CD, contact point B and C. Okay, start. Right, first, I'll do one thing. Consider AB. I'll do AB. I will write free body for AB. This is A, this is B. There is a point load here of 80 kilonewton at 3 meter from here. Then further, there is a support, fixed support. Since the load is going this way, likely chance is that most probably, with assumption. See, when you apply load here, reaction will come like this. HA. See, you should not tell, sorry, MDSD Kani, you took right side. MDSD Kani gone. MDSD Kani gone. Okay. And if you apply load this way, likely chance that reactions are like this. HA and HB. Tell me. This HA is coming from the fixed support. This HB is coming from where? Tell me. That HB is coming from where? Tell me. The HB is coming from where? Can you tell me? That HB is coming from which one? Fast. That HB is coming from where? From where HB is coming? From which member HB is coming? BC. So if you want, I will put HBC, HBA, correct? H for BA, correct? Now I will call H for BA. Okay, this is HA only. Now also there are member end moments. Sorry, one more thing. Also there will be vertical reaction. See, now vertical reaction we are not bothered. Most probably the reaction will come like this here, VA, and here from the beam a downward reaction load will come, maybe VBA. Chance is there. You don't worry about it now, because why? When you take moment, VBA, VA are not there. But very important, moments are there. At A, clockwise moment of 0.12 kilonewton meter. At B, it is what? Once again, clockwise moment of 91.27 kilonewton meter. Okay, or do one thing. The vertical reaction, you don't write name. I will put later. I will tell later for that one. Don't write. Show the reaction. Now, take moment about B. A, B. This is A, this is B. Take moment about B. Take clockwise positive. Okay, moment about B. Full height is 5 meter. Moment about B. HA into 5 clockwise plus HA into 5, then minus 80 into 3 anti-clockwise, then plus 0.12 also plus 91.27 equal to 0. You get the value of HA. Tell the value of HA with sign. Fast. You get the value of HA with sign. Give the answer fast. This is HA value assumed to left side. Answer fast. Do not waste time. Fast. Oh, if you do this way, today we cannot finish the question. I will tell you some more important concept. You will be later wondering, oh, these are all there. I never know. 8 into 2. Okay. Confusion. Anyway, nothing to worry, because I already got the answer and noted down there. So if the mistake is, if this mistake is there, what value you give, I will look there and tell, no, not possible, because I carefully calculated earlier. Okay. See, this is called print mistake. It is not by mistake. See, I told here 80 into 2, 3 I told. Actually 2. Print mistake. Answer. But give the answer with sign. No, you should give the answer with sign. Whenever you find something based on sign convention, remember, you always write the answer with sign. Plus 13.72. Congratulations. It is plus 13.72 kilonewton. Okay. Then sigma H equal to 0. Take right side positive. Okay. Minus HA minus HB, HBA minus HBA, then plus 80 equal to 0. That's all. You know the value of HA. Substitute for HA and tell me what is the value of HBA you are getting. Fast. What is the value of HBA you are getting? With sign. Tell with sign. Tell with sign. Plus the hale answer. HBA. Reaction at B for BA member. ಇಷ್ಟೊತ್ತು ಬೇಕಾ ಇರೋದೇ ಒಂದು ಲೋಡ್ 80 HA is equal to minus plus 13.72. This much time for sigma H plus 66.28. Thank you. Plus 66.28 kilonewton over. Now make a note. We assumed the horizontal reaction because the load is acting this way, we thought it will be like this. Both came positive. That means when I go for the final entry, both of them I will enter in the same direction as assumed. Clear? Both of them later in the free body, when I want to SFD all, I will enter in the same direction as assumed without sign. Clear? I will enter in the same direction without sign. Past tell clear or not? Clear. By chance, imagine you get negative sign anywhere. Then when I enter later, I will enter it without sign in a direction opposite to the assumed direction. Okay, over. Sakbidi. Next. Consider BC. Consider BC. When you consider BC, see, BC is here. There is a point load of 25 kilonewton, one more point load of 30 kilonewton. And there is a reaction here, there is a reaction here. This is reaction at, this is the point B, this is C. Reaction at B, vertical reaction for BC, vertical reaction at C for CB. Then there will be some horizontal reaction. We are not interested. Because you cannot get it. If you apply sigma m, sigma v, you get. Suppose you apply sigma h, two unknowns are there. Axial force you have to get using a trick later. So these are not required for us, time being. Anyway, when you take moment, it has no effect. And moment, there is an anti-clockwise moment of 91.27 kilonewton meter, a clockwise moment of 18.40 kilonewton meter. Remember that 40 kilonewton is acting externally from outside. Don't consider it. Okay, start. Length of member is 10 meter. This is 3 meter. This is 4 meter. So if I take moment about B, clockwise positive, I will get minus vertical reaction VCB into 10 plus 25 into 3 plus 30 into 6, then plus 18.4 minus 91.27 equal to 0. Tell me what is the value of VCB you will get with sign in kilonewton. Answer. I told you, when you apply sigma m0, sigma v0, you can find only reaction normal to member. For column, you can get horizontal reaction. For beam, you will get vertical reaction. Answer. VBC. Little past. Atmantu. Second decimal accuracy. See, I want second decimal accuracy sufficient. So therefore, lastly, while balancing, some 0.01 difference is not a problem. Plus 18.21. Thank you. Plus 18.21. Sigma V equal to 0. Upward positive. You get plus VBC plus VCB minus 30 and 25. Minus 25 minus 30 equal to 0. You know VCB value. Therefore, you get the value of VCB. Answer. Fast. Plus. We get what? You get VBC. You get VBC. VBC will come plus 36.79 kilonewton. Correct or not? Plus 36.79. Correct answer? Tell me correct or not? Okay, over. Now, last member. Some space required for me. Oh, yes, I got here. I can write here. Because why? Consider CD member. CD. Okay. Write the member here. This is C, this is D. The height, length of member is 4 meter. Anywhere right. There is a UDL here of 18 kN per meter. that 40 kilonewton, don't consider. It is a joint load. It is common for both. I will tell the concept later. Now, this is 4 meter over. Now, because the load is this way, every chance is that horizontal reaction will be like this. I will assume like this. HC and HD. This is HCD. HCD. SCD. Okay, now, there will be vertical reaction. We don't require it. Then, there is a moment here that is anti-clockwise of 18.440 kilonewton meter, a clockwise moment here of 57.29 kilonewton meter. Okay, now sigma m about any point will do. I will take moment about C. About C equal to 0, take clockwise positive. Minus HD into 4 minus HD into 4 plus 18 into 4 is the total load into 4 by 2 clockwise, that's all, plus 57.29 minus 18.40 equal to 0, you get the value of HD. Tell the answer. You get the value of HD in kilonewton. Fast. You get the value of HD in kilonewton. Little fast you have to give the answer. You are wasting lot of time. That's why now later courses, all basic courses, I decided better go for recording only, where time is not wasted. Live class means what? You are participating, but lot of time is wasted because no response. Nodi, innu bandila answer. Innu answer bandila. 68.31 ಅಲ್ಲಿ ಬೇರೆ ಇದೆ. ಯಾವುದು 68.31? ಅಲ್ಲಿ ಬೇರೆ ವ್ಯಾಲ್ಯೂ ಇದೆ. ಅಲ್ಲಿರೋದೇ ಬೇರೆ. 45.72 ಇದೆ ಅಲ್ಲಿ. 68.31. ಅಯ್ಯೋ ಅಬ್ಬಾ, my answer is different there. My answer is correct, I know it. You made a mistake. How 68 will come? First of all, which is the calculator you are using? How 68 will come? See, again same problem. No reply, one line answer, wasting time. That's why sometimes it gives what? Some irritation feeling. No answer comes. When I write everything, plus 45.72 plus 45.72 kilonewton. Okay, then make sigma h equal to 0, not sigma v. Right side positive. Then plus HD plus HCD minus 18 into 4 is the total load equal to 0. Therefore, you get the value of HCD. Oh, last answer. Over. Answer. Now I will tell you how to write free body diagram. Answer. HCD. Over. Calculations over. Now only tricks are there. If you tell HCD, my work is over. Plus 26.26. Correct. 26 28 ಇರಬೇಕು ನೋಡಿ. ಅಲ್ಲೂ ಕನ್ಫ್ಯೂಷನ್ ನೋಡಿ. 26.28 ಇರಬೇಕು. ಅದಂಗೆ 26 ಆಯಿತು. ₹2 ನುಂಗ್ಬಿಟ್ರಿ. ಪ್ಲಸ್ 26.28 ಅದಂಗೆ 26 ಬರುತ್ತೆ. ಅಲ್ಲಿ ಎಂಡಿಂಗ್ ನಂಬರ್ 28. ಓಕೆ, ಓವರ್. ಮೇಕ್ ಎ ನೋಟ್. Therefore, we got reactions normal to member for all the members. Tell yes or no. We got reactions normal to member for all the members. Tell yes or no. I want confirmation. Yes. Now that's all. We can go to axial force diagram, shearing force diagram, and bending moment diagram. But remember, there is a problem. The data we got so far, is it sufficient for shearing force diagram? See, is the data we got sufficient reactions? Is it sufficient for SFD and BMD? Tell me, what reactions we got? Is it sufficient for SFD BMD? For SFD BMD, we want forces perpendicular to member and moments. Yes, but this data, what we got so far, is not sufficient for what? Tell me. You need extra information if you want what? If the purpose is only SFD BMD, over. Work is over. But it is not sufficient. If you want to draw axial force diagram, remember that I will tell the trick. What all I tell, you practice 100 times. Okay, leave it. Now, I will tell you one thing. I am rubbing everything now. Everything I am rubbing. Actually, I can remove this one, correct? This result I will remove. Not required. See, I will tell you one thing now. Okay, better. Momentarily. Here. I will tell one thing. Little later, I am going for free body diagram. Free body diagram. Free body diagram. At that time, what I will do is, when I consider AB, I will enter HA this way. How much? HA. No HA like that. Numerical value. HA. 13.72. Top reaction, this way HBA, I will enter 66.28. Okay, then when I consider BC member, I will enter this reaction to 36.79. And this reaction, I will enter 18.21. And later, when I consider CD member, I will enter bottom reaction right side of 45.72. 45.72. Top I will enter 26.28. Because I am rubbing everything, correct? This is the result we got just now, correct? This is the result we got just now. Tell yes or no. Fast. Tell yes or no. Everything positive came, therefore same direction. Anywhere if negative comes, enter reverse direction. Okay, now full I will rub it out. Very, very important. Now you have to go for other data. See correctly what to do. This all I will remove. Idu beda. Aitala, idu aitu. Manegu. Okay, now see. Lastly, for axial force diagram, shear force diagram and bending moment diagram, consider or draw free body diagram for all three members. Whatever reactions, that is reactions normal to members, or whatever are the reactions are already calculated. Therefore, enter them. Wherever positive came, enter in the same direction as assumed. In case you get negative, enter in the reverse direction, no negative sign. Also enter member end moments and loading and distances. Okay, 1 minute now. See, AB member. I'll write here. See, somewhere here I'll write AB member. Some gap required for me. This is BC member. This is CD member. Separately A, B. BC, CD. AB member, there is a point load here of 80 kilonewton at 3 meter. Member is 5 meter. BC member, 2 point loads 25 kilonewton and 30 kilonewton at 3 meter here and 4 meter here. Span is 10 meter. CD member, UDL of 18 kilonewton per meter, and then this is 4 meter member. Now, for AB, I got reaction this way of 13.72 kilonewton. Here, this way reaction of 66.28 kilonewton. For BC member, I got this way reaction of 36.79 kilonewton. This way reaction of 18.21 kilonewton. For CD, I got this way reaction of 26.28 kilonewton. Here reaction this way of 45.72 kilonewton. Some brainy person in YouTube, he added these two like his usual. VB1 plus VB2 wrote the combined reaction. Extra brainy person. Okay. Then loading reactions are over. Also, I am using red color for reactions normal to member. Clear? I am using red color for reactions normal to member. Clear? Red color for reactions normal to member. Then member and moments already over. It is not unknown. I will use black color. Illi. Clockwise moment of 0.12 kilonewton meter. Illi. Clockwise moment of clockwise moment of 91.27 kilonewton. Randomly I am writing anti-clockwise of 91.27 kilonewton meter. Clockwise of 18.4 kilonewton meter. Anti-clockwise of 18.4 kilonewton meter. Clockwise of 57.92 kilonewton. Okay. Now, lastly, I want what? Those reactions which are axially passing. Tell purpose. That is, for the column, I want vertical reaction for the columns. For the beam, I want horizontal reaction. Tell me, purpose. See, this much data is sufficient to draw SFD BMD. Make a note. You take a screenshot and tell. This much data is sufficient to draw SFD BMD. But I also have to draw axial force diagram. For that, I need for columns vertical member, the force along the member, vertical reaction. For horizontal member, horizontal forces. Clear? Okay. Now, I am going to use blue color for that one. Blue color for that one. It's not writing. Blue color pen agaytalla. Notini. I will use blue color for that one. Blue color. I want this reaction, this reaction, this reaction, this reaction, then this reaction and this reaction. Clear? You should do one thing. Once you take a screenshot and write, then write once again with what? This blue color. Clear or not? Axial force diagram will give you for a column. It's very important. What is this one? When you design a column, axial force is the most important term. Why explain? Axial force is the most important for column. For beams, it is not required. But we will draw. In structural analysis, we never bother importance. We draw everything. In structural analysis, we will draw everything. Practically, for column, axial force most important. Okay, now, correctly see what I am doing. These forces, reacting forces, along the member, you have to decide by inspection. See what I am going to do. 1 minute. What I am going to do. Nodi. Start from joint B. Nodi. Joint B. For beam BC, there is a vertically upward reaction 36.79. Nodi. This is first number 1. I am starting from here. For the beam, what all I am going to tell, you have to write again and again. Practice. I will tell only once. Because later everything is entered. You should go through the class again and again. Start from here. For beam, there is a vertical reaction 36.79 up. That is the reaction for the beam from the column. So 100% from the beam for the column, tell the vertical load transferred, tell the answer. 100%. From the column to the beam, there is a vertical reaction of 36.79 up. So, from the beam to the column, for joint equilibrium, what is the load transferred from beam to column? Answer. You are again not answering. What is the load transferred from beam to the column? Same magnitude in opposite direction. So, from beam to the column, there will be a downward load of 36.79 kilonewton. Remember how you got it? This one reversed. Fully clear? Oh, we got fully clear or not? You should go through the class again and again. Full clear? Okay. Now, same way, come here. This is number 2. For the beam from the column, there is a vertical reaction upwards of 18.21, means from the beam to the column, 100% there is a downward reaction or load transfer of 18.21. Direct answer. This is based on this one. This also clear? Past. This also clear? Okay. Now do one thing. Come here. This column is getting a downward load of 36.79. So tell me, at the base, what reaction will come? From upper side, a downward load of 36.79. So at the base, there will be an upward reaction of how much? Tell me. How much reaction? 36.79. This you are writing by seeing this answer. By seeing this answer, you can tell this reaction. Tell me, clear or not? Okay, same way. For this column at the top, downward reaction of 18.21. So, it will come down. So, here there will be an upward reaction of same 18.21 here. This you got by seeing this one. Now, we got axial forces for the column. Once you get the reactions for the beam, once you get the vertical reaction for the beam, when you reverse it, you get axial forces for the column. Clear or not? Fast, tell me. Clear or not? Clear or not? Don't waste time. Till diagram you have to draw. Clear. Okay, now only pending is axial force for the beam. Start. Come here. There is a force of 66.28 to left side. This is the force on B column from the beam or relative force. Tell me, for equilibrium for the joint, if it is 66.28, tell me what is this force? Tell me. If it is 66.28 for the column from the beam, from there, if you can imagine for the column from the beam, a force of 66.28 is coming, means from the column to the beam, what will go there? Tell me. Same 66.28 to right side. It is 66.28 right side. This we got by seeing this answer. Correct? By seeing this answer. Clear or not? Okay, now consider the beam. Left side, there is a right side force of 66.28. Beam should be in equilibrium. If you push the beam by this way, tell me what force will be there here. If it is right side here, for equilibrium for beam, tell me, is the force here right side or left side? Fast. Is the force here right side or left side? At the right end of the beam. If it is 66.28 this way, here, it is to left side of how much? 66.28. How you got it? By seeing this answer. Over. Now, full clear, tell me. Full clear. Everywhere we got reaction. Full clear, free body. Okay, now I wrote roughly here. Tell why? Because so much things I told. This is using that one. I wrote roughly because neatly entry is somewhere there. I'll show you. Very beautifully I entered there. Okay, now one small concept. Let me see this question, this concept I am uploading in YouTube. Under a special name. I am challenging everybody, people who got structural knowledge, to answer the question. Now, 1 minute. Just see joint C. There is a left side force of, if I see the joint C here, a left force of 18.4 and a right side force, 18.4, a joint C here, see, if I write the joint C here, there is a left side force of 66.28 and there is a right side force of 26.28. Therefore, is the joint C in equilibrium? See here. Clockwise 91.27, anti-clockwise 91.27. Equilibrium. Clockwise 18.4, anti-clockwise 18.4. Equilibrium. Down 36.79, up 36.79. Equilibrium. Up 18.21, down 18.21. Equilibrium. Left 66.28, right 66.28. Equilibrium. But left of 66.28, left of 66.28 and right of 26.28. Tell me, is it in equilibrium? Tell me, answer. Is it in equilibrium? No, tell me, is it in equilibrium now, at present? I told everything once again. Why should I repeat? I told everything so far. Is it in equilibrium? No. There is a net force of how much? 66.28 left side, 26.28 right side. So these two will have a net force of how much? Net horizontal force of how much? Tell me. 66.28 left side and 26.28 right side. Net horizontal force of. There is a net horizontal force of how much? 40 to what side? 40 to what side? How? See correctly. 66.28 to left side, 26.28 to right side. So net horizontal force of 40 to left side. To left side. Oh, there is a problem. From outside, there is a joint force of how much? Tell me. From outside, there is a joint force of how much? Tell me. Now see the frame. Now see the frame. From outside, There's a joint force of 40 left. Here also net force of 40 left. So net answer, internally 40 left, externally 40 left. Total. These all is 40 left. Externally 40 left. Total 80 left. Is it possible? Tell me. I am sitting here now. You can't see me. Because if you see me, you will see how I am laughing. So I don't want to laugh in front of you. See, my face expression will change. Better I sit here. Looks very odd or not? Externally applying 40, internally also 40, same way. Is equilibrium is there? Is equilibrium is there? First. Is equilibrium is there? Tell me whatever comes to your mind. Is equilibrium is there or not there? First. Again see. You are at present no. Looks very odd. See. If externally there is a 40, internally, if externally 40 is to left side, internally 40 should be what? To left or right side. From externally, if 40 is to left, internally 40 should be to what side? 40 should be to what side? When externally 40 is to left side, internally 40 should be right side. But unfortunately, externally 40 this way, here also 40 same way. It will add up and spoil the equilibrium. Yes or no? Equilibrium is spoiled. Tell yes or no? Equilibrium is spoiled. Looks very funny. But number tallied. See, I got 40 only. Yes. My answer, no. Equilibrium is not spoiled. It is perfectly correct. I am going to ask the question in the YouTube for the people who think they know too much of basic. I will tell them, come on, answer the question. Come on, answer the question. Okay. Anyway, time being, you believe me. Agreed? Right now, you do not bother about it. See, once you get 66.28 here, you write same answer here, and believe me, it is in equilibrium. Will you believe me? If I tell it looks like not in equilibrium, but I will tell this way, it looks like not in equilibrium, but I am telling you it is in equilibrium. Will you believe me? Tell me. Will you believe me or not? Will you believe me? I am telling it looks like not equilibrium, but it is in equilibrium. Yes. One person, I don't want to tell, from past 2 years, he is a high level. He is struggling to give one of the answer for this one. Whatever he tells, I will give other way answer. Then first he told me, sir, give me 24 hours time. Then I told, not 24 hours, I will give 24 days for you. He told, not required, 24 hours sufficient, I will get the answer. I told, okay, you can get the answer, but anyway from my side, take 24 days. Such 24 days, it has become more than is nearly 2.5 years now. Still I think, I know, still he is struggling, scratching his head. What is happening here? Confusion. But I told him, I will not tell the answer. He told, no, I will get in, within 1 day I will get it. 1 day gone, now it is more than years together. Okay, leave it. Now, this point, I am not explaining to you, one suspense for you, no problem. One suspense for you, no problem. It will be uploaded in YouTube with the solution. With the solution, it will be uploaded in the YouTube. Okay, now we are ready for SFD BMD. 1 minute. I want a small break. Today class may run little more. Okay, now, shall I remove all this now so that I can draw the diagram? Shall I remove everything so that, no. I cannot explain openly. If I explain openly here, How I can ask the question in YouTube? How I want the people to understand that there are beautiful concepts in structural engineering. There are concepts. People who think they got mastery, they should think, oh, we still have to learn lot of things. Okay, now, shall I remove all this? Shall I remove all this? Ready for SFDBMD. I want around 5 minutes rest because non-stop I talked. Shall I remove all this so that make board ready? Full I am removing now. This concept, okay. Full gone. Now see, I will draw all the diagram. I will tell you something else also now. Note. I will, furthermore, the frame I am not removing. For some reason, frame I am not removing. But, okay. Parvaila. Okay, see, remember, finally we got the vertical reaction by transferring. Yes or no? By transferring, we got vertical reaction for the column. Correct? By transferring, we got vertical reaction for the column. Yes or no? Now I will tell you one thing for you before you proceed. See, now, suppose you consider, see now, this is unwanted, only for information. Fast give the answer. Class will go a little more time. Suppose I consider only free body of CD and take moment about C equal to 0. See here, if I take the reaction like this, then minus HD into 4, then plus 18 into 4 by 2, then this moment is clockwise of, you know this moment, clockwise of 57.29. This moment is anti-clockwise of 18.4 equal to 0. Your HD will come, how much it came? Plus 45.72. This already clear. So this HD equal to 45.72 kilonewton. Tell me, clear or not? Fast. One extra concept I will tell you. Clear? Fast. Okay. Now, I got the vertical reaction here. How I got it? This vertical reaction VD, I got by transferring. I can do one thing. Consider free body of B, C and D. Nodi. Unwanted, this free body you consider. Then this moment will not be there because this moment will cancel. Yes or no? If I consider free body of B, C, D, this moment will cancel. Tell yes or no? Those moment will cancel. Tell yes or no? And of course, there will be a moment here of anti-clockwise of 91.27 here. Now do one thing. Take moment about C. Take clockwise positive. Nodi. Iga. Minus HD into 4. Then minus VD into 5, 10. Minus VD into 10. Plus, its moment plus this moment. That moment is 57.29. And then plus clockwise 18 into 4 is the total load about this point. If I take moment into 4 by 2, this has no moment, plus 30 into 6 plus 25 into 3 minus 91.27 equal to 0. HD we already got plus 45.72. Tell me what VD will come. I will take a break. You calculate what VD. By earlier when I transferred from Earlier, we already know VD by some other principle. This is finding VD by partial equilibrium. Partial equilibrium. Then earlier answer for VD was 18.21. Earlier was plus 18.21. Tell me, is the same answer comes or not? If it is not coming, I will not continue the class. You comment, is same answer comes or the unwanted part. I just told you how you can play in the structure. How you can play, I will show it. Okay. I will take just 5 minutes break. You type, is the same answer comes or not? Only 5 minutes. Okay, sufficient. I'll start. Time is not there. Now I will do one thing. If you want to understand correctly, see, actually playing. I will tell how I can play. Just 1 minute. Or I will consider first free body of CD, get HD. Not moment about B. I will take moment about A. Then this moment will vanish. This moment will come. Then you get minus BD into 10 plus HD into 45.72 minus 8 into 4 into 5 minus half of 4 minus 40 into 5 plus 30 into 6 plus 25 into 3 plus 80 into 3 and then plus 0.12 equals 0. You are going to get VD equal 100%, 18.21. Or if you consider first free body of BA, take moment about B, get HA value. Once you get HA, you put VA here, take moment about that point, you are going to get VA equal to 36.79. Or you take free body of this member, take moment about C with this moment, again you are going to get VA equal to 36.79. My guarantee. That is, there are so many ways of finding reaction. No, anything. You got so many alternatives. Okay. Now, when I asked that question later, someone asked me earlier. See, I told him one more question. See, suppose there is a joint, you introduce a moment of 100. Imagine this gets 60, this gets 40. Oh, same problem here. 100 outside, 60, 40 inside. Again, no equilibrium. Same as forces. Then somebody who knows subject little, he told, sir, it is induced. I told him, tell me where is equilibrium. That's all I want. Sir, no equilibrium. What do you mean by no equilibrium? Then he told, sorry sir, leaving it. Okay, anyway, these all I told just for fun. You correctly, what I told earlier, you stick to it. The numbers are actually, what happened is rubbed out. I am overwriting it here. Therefore, some color change will be there. Okay. Right. Now I will go for diagrams. See, what all result I got, I systematically entered there. See now. Systematically entered there. Can you see the answer? Tell me. What all answer we got is fully visible. Is the free body? Oh, no. It turned. Camera turned a little. 1 minute. Camera got turned a little. Is it fully visible? What all result I got earlier? I made a neat diagram there. Everything. Yes, visible? Okay. That's all. Okay. I will start SFD BMD now. Okay. See correctly. This is what? This is free body diagrams of AB, BC and CD. Free body diagram. Remember, all values are actual values. No sign convention. Anything negative, we make reverse. Now, first, draw axial force diagram. It won't take much time. Common sense is sufficient to draw axial force diagram. Nodi. Axial force diagram. This is the original member. What you will do is, when you draw axial force diagram, I will take values are in kilonewton. I will take tension positive. Some sign required. No. This question actually what happened is, tell me, all members are in what? Tell me. Why tension positive? Here, you can see there. All members are in what? Tell me. You can see there. All members are in what? Axially. See there. Tension or compression? Why take tension positive? All members are what? Compression. So, it is better to take compression positive. So, compression positive. Or you can do one thing. Without sign. Tell me. For member AB, wherever you see axial force is 36.79 compression. Correct? It is 36.79. Here also 79. It is compression. For this member, wherever you see axial force is 66.28 compression. 66.28 again compression. For this member also axial force is 18.21 compression. Suppose compression tension both are there, you write C and T or tension positive. Is axial force diagram clear? Past. Any member, anywhere you see, it has got axial force of this one. Clear axial force diagram? I wrote because let it be there. When you solve a problem, we should complete it. Axial force diagram clear? Okay, now draw shearing force diagram. I will draw here. Here I will draw. Shearing force diagram. Now remember, no gap now. No gap. Okay. This is shearing force diagram. All values are in kilonewton. See, start. Sign you can decide later. Okay, start here. Do one thing. Start from here. This member. Go left by 13.72. 13.72. No load up to here. Up to here. Come right by how much? 80. So this value will be 66.28. No load up to there. Go again parallel to baseline. Come back by 66.28. This is shearing force diagram for member AB. You can take any one of them plus other minus based on some sign convention. Okay, not required. Go to BC. Go up by 36.79. 36.79. No load up to here for around 3 meter no load. Come down by 25. Till a little value is left. How much? 36. You are not, because you are not telling. You are not telling the answer. So I am calculating. You are not telling. If you had told the answer, it would have saved some time for me. 11.79. Then no load up to here. Come down by 30. It will come 18.21. It will come 18.21. No load up to here. Go back. This is the shearing force diagram for the beam. One of them plus other minus. Your sign convention. Lastly, this member. Continue from here. Go right by 26.28. From here to here, come left by 18 into 4. It will cross the baseline here. When you reach here, it will be 45.72. Okay. This is the shearing force diagram. Now, this is the point where SFD crosses baseline for column. This is the point where SFD changes sign for beam. This is the point where SFD changes sign. I want this distance. Do you know how to get it? I won't waste time because I have covered all earlier so many things. Shall I put direct answer? I won't explain now because if I explain, it is a waste of time. Do you know how to get it? Tell me. Oh, someone told the answer also. Very good. It is 1.46 meter. Yes, that is good spirit. That is what is called studying interest. See, correct. It is 1.46 meter. Thank you. Nanda Kumar told you 1.46 meter. After the class, I will call you. Please tell me how you got it. Can you help me? After the class, I may call you because I got some confusion. Can you help me after the class? After the class, I will call you. Can you kindly help me how you got it? Help martira? Igalla class admele. Are you only taught? Okay, leave it. Now, some new points are there. See, this point is A, this is B, this is C, this is D. Now, new point. I will call the new point as E here. This I will call F here. This I will call G. Okay. Now, bending moment diagram. Now, to draw BMD. Very careful. Sign required. On 1 minute now. Is it fully visible for you? Can't I tell? Okay. Now, bending moment diagram. This I will remove. I will remove this one. Okay. Start. Show calculation. I will do it. Bending moment calculation. Be careful. Consider AB. Consider AB. Now AB member, there is load this way. So I will take sagging positive this way. But remember, I will take sagging positive. Okay, start. Correctly observe. Bending moment at A is sagging plus 0.12. All explain. I will take for this member C, I will take what? Sagging positive this way positive. So BM at A plus 0.12. BM at A is plus 0.12. BM at B. BM at B equal to, it is hogging minus 91.27. These all I explained earlier. All calculations are in kilonewton meter. Then BM at ಯಾವ ಪಾಯಿಂಟ್ ಅದು ಈ ಪಾಯಿಂಟ್ ಏನು ಹೆಸರು ಒಂದು ಎಕ್ಸ್ಟ್ರಾ ಪಾಯಿಂಟ್ ಇಸ್ ದೇರ್ EFG I will call this as H point ಆಯ್ತು ಬಿಡಿ H BM at H is here ನೋಡಿ +0.12 then plus 31.72 into 3 tell the answer +0.12 plus that this all I explained earlier. Those people who got difficulty refer my earlier case of one frame in the class where the frame was like this. See this type of frame I explained for you. You go back to that class and come back here. Answer. ಸುಳ್ಳು ಹೇಳಬಾರ್ದು ಬೇಗ ಬೇಗ ಆನ್ಸರ್ BM at H plus 41.28. That means plus means it is sagging, minus means hogging, plus means sagging. Here tension is right side, tension is left side, tension is right side. Therefore, when I draw BMD for that member, what I will do? When I draw BMD for that member, here I will plot 0.12 inside, very small value. And here I will plot 41.28 this side. Here I will plot positive inside 41.28. Here tension is this side minus 91.27. BMD will be like this. If you want, this is BMD on tension side, no plus minus. BMD on tension side. Those who are regularly coming to my class, I explained everything. Newcomers, you have studied old classes. No sign. That is, this much portion is sagging, this is hogging. It should join to 0 here, 0.12 here. Ayyo. Jarta ide. Okay, small value. Okay, now, BMD for beam. For BC member, bending moment at B, I will take sagging positive. Bending moment at B, minus 91, bending moment at B, minus 91.27. That means hogging BM, tension upper side. BM at which point? E. BM at E is minus 91.27 plus 36.79 into 3. Tell the answer fast. Answer fast. Answer with sign. Bega. Fast answer with sign. Don't give wrong value. Everything we did correctly. Why make mistake? Minus 91.27 plus 36.79 into 3 plus 19.1. Plus means what? Sagging BM, tension down. Then BM at F. Here, F. Look this side. Minus 18.4 plus 18.21 into 4. Tell this answer. Minus 18.4 plus 18.21 into 4. Answer fast. Getting late. I am doing little fast because I have given too much importance to free body. Plus 54.44. That means it is sagging, tension below. Lastly, BM at C is minus 18.4 means hogging, tension top. So here, tension top of 91.27, here tension top of 18.4, somewhere here under the point load, first point load, 19.1 tension down, small value, 19.1, somewhere here at 4 meter here, 54.4 tension down. Okay. 54.4. Therefore, your BMD will be like this. BMD on tension side. Lastly, member CD. Member CD. Member is loaded like this. I will take sagging positive. This is sagging. Okay. Bending moment at C. This is sagging. It is hogging minus 18.4. Means hogging tension right side. Bending moment at D also. At D is what? It is bending what? This way. It is hogging minus, no clockwise, anti-clockwise, 57.29, hogging tension right. And lastly, bending moment at that point G. Here, look this side. Minus 18.4 plus 26.28 into 1.46 minus 18 into 1.46 into 1.46 by 2. Tell this value fast. If you tell the value, everything is over. If you tell this value, everything is over. If you tell the value, everything is over. Last answer from your side for me today. Sorry, you are not giving answer. Last answer from you. Plus 0.784. Check ಮಾಡ್ತೀನಿ. That is, its reaction ಎಷ್ಟದು? 18.4 square. 18.4 square divided by 36 minus reaction ಎಷ್ಟದು? 26.28 square divided by 18 divided by 36 minus 18.4. Yes, plus 0.78. Correct, plus 0.78. Very small value. It is plus 0.78. Plus means sagging tension inside. Very small value. 0.78. Your BMD will be this way. Okay. Lift ಸರಿಯಾಗಿ ಬಂದಿಲ್ಲ, adjust ಮಾಡ್ಕೊಳ್ಳಿ. ಸರಿಯಾಗಿ ಬಂದಿಲ್ಲ, ಇರಿ ಒಂದು ನಿಮಿಷ. That point is here, 1.6 meter. Okay. ಅಯ್ಯೋ, ಪ್ಯಾರಾಬೋಲಾ, ಇರಿ. Okay. This is 0.78. So there is a counterflexion here, counterflexion here, counterflexion here, counterflexion point. If you want, you can locate. This is the BMD on tension side. This is the BMD on tension side. Now, just for those who want superimposing principle, that is not correct actually. Only thing is, so many people are there, they know only how to draw BMD using superimposing principle. Fast I will draw it. Without explaining, I will draw it. I will draw it without explaining. Nodi, I will remove this one now. This is a correct BMD. People who want superimposing principle, I will tell what to do. Crude method. Inside 0.12, plot on the tail side, outside 91.27, here outside, then tail is outside, see, crude method, 18.4, outside of 57 point, 57 point, rubbed out, 57 point, 57 point, rubbed it, 57 point something, point something, okay, joined by a straight line. Whatever load given, joined by straight line. Now, superimpose the BMD for this member for simply support beam, WAB by L. Then, negative, positive and positive. Here, superimpose the BMD for simply support beam with 2 point loads. Draw it. You have to get it. Here, superimpose the BMD for UDL. Small value will come. WL square by 8. Negative, positive, negative. I don't want it because it is not correct. It is only academic point of view. Okay, now, do not, in my class, those who are coming for knowledge, do not see this one. Now, axial post diagram, shear post diagram, bending moment diagram, fully clear. If it is clear, I will close the class. If everything clear, I will close it. Full clear. Bending moment diagram, remember, I see sometime what happens is, people suddenly will come newcomer now. They will tell bending moment, he explained everything properly. BM, he has not explained proper. Go back to old classes. Frames, I explained bending moment diagram earlier. After all, 3 members. I had done a frame of 3 plus to 5 member beam, a big frame, BMD drawn. Do anybody who want to learn from me, they should see all my classes and not like a entertainment video. Go through each and everything, make a note. That is strictly followed. My class is not for time pass purpose. Okay, thank you. We'll meet next time. I will announce you when is the next class. One frame I will do by big frame by Kani's method and solve by software. Clear? For those who are in the back, that will be only in Zoom. It won't be in YouTube because by YouTube I can't use software. One I announce a class, when maybe next Tuesday, I will take a frame because tomorrow steel class is there. I will take a frame, what? Analyze by Kani's method and simultaneously analyze by software. That is E-tabs. Compare the result. Okay, thank you.